I'm going to talk about project management, about process, about technology. It's going to be less software, a little bit more process, working methods, and I think value. So value recognition on how you actually can succeed in your management using these sophisticated tools. Okay. I put myself and my contact information up front, and the reason for that is I'm here to learn today, but also here in order to find new customers. I'm here to find new partners, and what I'm going to talk about is, I would say, my passion in life, which means if you agree on something, come and tell me after the presentation. And if you heavily disagree with what I say, come and find me after the presentation. All right? But here you find my contact information. Anything you think about after the presentation, please contact me. I work for a company, or actually I run a company named Byggnadsekonomi. It's a Swedish name. It translates in English to construction economics. So even if it's very, very complicated to say in both Lithuania, I guess, it's also almost impossible in Finnish, where I mainly work. It has a meaning. We are a group of consultants. We are 16 people working from 2 offices. We have an office in Helsinki, office in Stockholm, Sweden. We delivered more than 300 BIM projects over the last years. We trained almost 3,000 people on the focuses on scheduling and using 3D models, using BIM for production management, and taking the technology out on the field in order to run cost and time with the technology. One of the main focus is the BIM management, on how to run the process, how to make the models to actually receive those goals that you're looking for. It's a question about building up a BIM strategy, guiding your consultants to do the type of design, to work in the tools, so that you, as an owner of the project or as a project manager, actually get what you are looking for in the model. We talk about strategy, we talk about estimating, we talk about scheduling. We do both, or actually all 3 of those. Our estimators are full-time estimators. They calculate projects, they set the budget, and we run the projects towards that budget. The same way when we work with scheduling, we stand behind the schedule and we run the project all through production to make sure that it's delivered on time. Jukka said here earlier that 90% of the projects end up late. 40% go our budget. My passion in life, what I've been doing for the last 20 years, is to make sure that none of the projects I work on ends up in that situation. Some references before we go to the topic. Easton Helsinki was the Tekla BIM Awards winner of 2017 in Finland and Balticum. We had the full responsibility of the BIM coordination and management, as well as the full responsibility of scheduling from the very first draft until delivery of the project. That was, by the way, delivered on time and budget. The other one, OP Vallila, was the winner of Tekla Global BIM Awards, awarded the best total BIM project in the world 2015. That's a 90,000 square meter office complex in central Helsinki. Other references that might have come over the news, that you see it internationally, are Tele2 Arena in Sweden. I'm going to show you some examples from there. Värtaterminalen, which is a harbor in Stockholm. We have Mall of Scandinavia, that up until a few weeks ago was the largest shopping center in Europe. We have Amos Rex, a museum that won the Finlandia Prize of the building design, new hospital, and some other stuff. All right, agenda. We're going to talk about successful project management. We're going to talk about the technology behind it and how to utilize it for production. We're going to talk about the power of scheduling, which is my real passion. After doing it for so many years, I may say I am a professional scheduler. I do it a lot. I do almost half of my time is pure scheduling on projects. We're going to talk about data and how it moves and how it evaluates during the project. It's not an easy topic to start with, successful project management. Come on, if there was a certain success factor, you do it like this, everybody would do it. When I talk about it, I always talk about the principles of performance management. And that is not something that is only construction industry. It is any industry, it is any economic, it is anything you want to get done. You should follow the principles of performance management, which means that you define goals. You have to set up some concrete goals of what you want to achieve. And you have to communicate it to every single team member so they know what your goals are. That also becomes their goals. It has to be challenging, which means that you have to put in some effort in order to get there. But it also has to be reachable. Number 2, monitoring the progress constantly. You need to keep track every single day or minute on what is going on so that you understand how well what is happening in your project is corresponding to what you have planned in order to reach your goals. And for the third one is the control actions. When you have the goals and when you track the proceeding and there is a deviation, what are the control actions that you do immediately that will bring back your project to the defined track heading for your goals? So this means that the most important part of performance control is to ensure that you are proceeding as planned. Now, in order to do that, you need a high-quality plan for a basis that you can do the tracking on. And then we go into BIM technology and the power of all the data that is available through BIM modeling. I'm going to show you shortly the process of BIM production management. Every tool I've run into so far is following almost or close to this process. You start up with the actual modeling work, so the design work where the design is created, and when you manage the process of how it is created, you end up with 3D models, you end up with BIM models. It is by setting requirements and managing the process, you end up with the model. Now, when you have a model, you immediately have position and geometry. So every modeled object knows what kind of a geometry it has. It has a physical position, as Kim and Jukka have shown. It has a position in the model. It has a position also in the world. If you're adding one more thing to that, which is classification or identification, so that you can actually find the specific object that you are looking for, like this column up there. And you know that this column is column type 1. The column type 1 has some work methods. So in order to build it, we know that we need to do certain things. We need to do the concreting, we need to do the rebar, we need to do the formwork, and we need to do the finishes. The fact that we know that we need to do something means that we can add resources to it. So we can break down, for example, the formwork, that it has to, in order to get it done, we need material, we need supplies, and we need people to do the work. And that brings us to scheduling and cost management, because grouping work methods combined with resources are the basis for any scheduling activity. And by giving unit price to the resources, we will know the cost of any single part in the building. Sounds easy. Now, what do we actually need to do in order to succeed with that? There are two main things that has to be right. First of all, reliable geometry. We must trust the geometry. And in order to be able to trust the geometry, there are some things that we need to do. We need to use the modeling tools correctly. Whether it is Revit, whether it is Tekla, or it's something else, we need to use the software the way it was intended to be used. We also need to understand how different people and different parties in the project handle locations. Locations for a site is one thing, location for a structural engineer is one thing, location for an architect is another one. The pictures on the lower side of it shows, for example, that an architect usually thinks as a floor is from the floor he's standing on up until the ceiling he can see. Well, the structural engineer thinks of a floor, which is the floor he's standing on, and the load-bearing structure below it. So we need to understand when we communicate with people that we communicate in the same way, on locations and on the geometry. We need to agree on the modeling of connections, how do we handle it, what is the requirements for it, and we need to decide on the general level of detail, what are we supposed to find inside our model. That I will get to a little bit later. When it comes to identification, so actually finding information in the model, you need some kind of classification system. I learned yesterday that there is not a national standard for classification and construction in Lithuania. However, I'm not really concerned about that, because in Finland, as you can see, we have at least 6 of them. We have one for construction, we have one for MEP, we have one for electrical, we have one for infrastructure, we have one for structural engineering. So which one should we use? It doesn't matter. You can pick any one, or any of it. You can use the Unicode system, there are international alternatives. The most important thing is that there is a structure, and the structure is logical, it has full coverage, and it is used consistently throughout at least the one design area that you're working with. Because otherwise you will not be able to communicate with anyone else in your team, and they will not be able to find information in your model. But when you do have these two things in order, so the geometry is there, it is reliable, and it is right. And you do have one identification, so you can actually find information, and it is built up so the full model follows the same structure. Then you can pick any single object out of the model, and you can read out of the geometry those quantities that you are interested in at that specific time. The picture here wants to simulate that you can get the net surface area of a wall, you can get the gross surface area of the wall, you can get the length of the wall, you can get the height of the wall, you can get the width of the wall, you can get the volume of the wall, as long as you can trust that the geometry is right and the identification tells you that this is wall type 1, you will be there. Then you can bring the information into databases. And in the databases, you use recipes to bring those geometry quantities into material, work, and need for supply. Each of them can then be added with cost information, unit costs, how much it costs to build it, or with time information, how many hours does it take to build it. I'm going to talk a little bit more about scheduling, but on the cost part, I know there are other people talking about cost later on. Combining cost visually to objects is really, really effectful. On the Stockholm Arena, it's a 240 million euro project, central Stockholm, built by Peab. We had estimators on site. So my colleague was working for several years as an on-site estimating, providing cost data on let's call it a daily basis. Now, every time you talk about cost, it gets complicated or it gets boring. So how do you want to show a very interesting cost estimate? I mean, it is like an Excel spreadsheet with a lot of numbers. Most people don't really either understand it or don't care about what's in it. This is a printout of how we used to do it. So when we had a cost meeting, we pick out the interesting cost as part of it. We connect it to the 3D picture to show physically or visually what cost is related to what construction part. When we say that the facade or the climate shell of this arena costs this much, why does it cost so much? Yes, because it comes from these parts that have these quantities and with these costs. And it can be on a detail level if the design is on a detail level, and it can be on a rough level if it is early design. So you can make your money visual. When you do it, you get everybody involved, everybody understand what you're talking about, and you get much more value compared to comparing just Excel spreadsheets. Let's go into scheduling and optimization and trying to figure out why 90% of every project is delayed, or why it shouldn't be delayed. Scheduling methods. I mainly work with 3 scheduling methods. The first one is Gantt. These are the lines that are similar in every single industry. It shows activity as function of time. It shows a line. When activity starts, it shows when activity stops. The absolute best thing about the scheduling methodology is that it is an international standard. Everybody can read it. You don't need to be a construction expert in order to read it. And honestly, in early stage of the project, you are mainly discussing with people that are not construction. They might be economic experts. It's easy to read, it shows the activity, it shows the time where you're going, and you can see on a specific time what activities are supposed to be ongoing. The second one is network planning. The network planning has the strength of showing dependencies. So you can tell how different activities are dependent on each other. So you draw it as a network. In the example you have here, you can see that activity number A needs to be first. After that, you can do activity B, C, D, and E. They are linked together when you go from left to right. You can also see that there is a branch that shows that after B, you can do F and G, and only then you can do E. Now, by adding length to those activities, so how long does it take to do a specific task, you find the critical path, which is defined to be the longest chain of activities in this network. Now, this brings your focus to what is important in your schedule. Because if you want to build faster, if you want to compress your schedule, you need to address the critical path. Because if you can make that shorter, then you can make the project shorter. It doesn't help to do anything on the blue activities because it's still not going to be faster production. Not always it's a question about compressing the schedule, and it shouldn't be. It is very often a question of maintaining the schedule once you have found the optimal solution. Then this critical path will tell you where should you put your management efforts. Because if you want to make sure that your project delivers on time, you're going to make sure that every single activity on the critical line is being done during the time frame given for it. Keeping in mind that every change that happened in the project will affect that line, so the critical line can switch easily from one chain to another, depending on design changes, injuries, new user for the building. Any change that happens can change that line. But if you have the full network under control, then you also know the conflicts of what's going to happen when something changes. The third one, flow line, line of balance, brings up a third area that is you cannot really see in the Gantt chart or in the network planning, which is the use of physical locations and how crews are moving inside the physical building and how they affect each other. I'm going to show a little bit more about that because I think out of the planning method, that one is the least known out of these. A good planner can use all 3 of them or several, and easily switch between those in order to make the best possible plans. In the location-based planning, what we do is that on the left side, we have the locations. So we break down the project into physical locations. We have building 1, building 2, building 3. Building 1 is divided into 4 floors, and the 4th floor is divided into 3 work areas, for example. You can describe any physical building hierarchically like this. Then you have the time telling what day, month, week, hour the work is being done. And the actual activities are drawn like lines that goes across this chart. You can see the starting point of the lines. Reading from above, you see what week it starts, you see what week it ends, and reading any specific time you can see what activities are supposed to be ongoing at that time. You can also see where the crew is supposed to be. So at this specific time, the black activity is supposed to be in the 3rd section's 6th work area. The green one is in the 2nd section and 6th area, and the last one, the gray one, is in the 1st section and 3rd work area. You can need 3 other things of this. You can see where the crew is going next. So you see that when you're done with section 2, you move on to section 3. So the work order. You can see number 2, what is inside one location, the activities that are going to happen. So if you look at one location and you look at it vertically, you see first the black one, then the green one, then the gray one. For example, first you build the walls, then you paint them, and after that you do the flooring. 3 activities coming after each other. The 3rd one shows us the area between activities. So the closer they are together, the more risk in the schedule, the further away they are, the more you can deviate from your plan without affecting other activities. As a planning method, it brings you an overview. So it compresses the schedule. When it compresses the schedule, it means that you can show location at the same time as time. So when you in Gantt need to show with 10 activities, the movement from 10 different locations, it is 1 activity in the line of balance. For a scheduler, it helps you because this is the main solution. The more complicated your project is, and the further you get into it and the more detail you get more and more of these schedules. And at the end point, the only one who understands what's in the schedule is the guy who actually did the schedule. And at some point, even he loses track of what was connected to what. Still, this is the most used scheduling methodology. This is a Finnish project. It is built by SRV a couple of years back. It is an office building. It is 7 stories high. It's shaped L-shaped. And this is the MEP schedule of electrical and plumbing work. Now the question is it a good schedule? It's not easy to know. It's in Finnish. But the thing is, it doesn't really matter the language, because you couldn't evaluate the schedule. The only thing you can see is the starting and ending point of activities and the length of the activities that are 120 days, 80 days, 40 days. How do you know? From the shape of the schedule, it's a little bit S-shaped. Now, this S-shape usually gives you a quite okay resource graph. But you can also see, if you are experienced in reading those diagrams, that it's a little bit back-heavy, which means that there are a little bit too many activities that goes on all the way to the end of the project, which is probably make a little bit of a hurry at the end. But that's it. It wouldn't help you to understand the text. You still wouldn't be able to tell more about that. Still, this is the kind of schedule that ends up on the owner's tables in every project. And what do? We approve them without knowing if they are good or bad. So this specific schedule in location-based view looks like this. Wow. Not as clear as my earlier example. However, what you can read out of this are these. So these are the problems in this project. So these are the days and weeks and months where there is absolutely no chance that the work is going to proceed as planned. Because on the first yellow dot here in December, you see there are 8 activities going on in the exact same location at the exact same time. The next problem is going to be in May, because there are 3 different locations where it all goes and collides, and then another one. And still, you see here, we have all these white spots. Now, what are the white spots? These are physical areas where known activity is going on for several days or weeks, because everybody wants to work at the same location at the same time a little bit earlier. So if we go back to this one. It's not easy to plan like that. Projects don't look like that. You don't do all activities in every location. But what if you could? Wouldn't it be nice if you could schedule so that every activity on the site would take 50 days? Every activity, always 50 days. It is possible. I mean, you're the manager of the project. You can decide that you use 1 person or 10 person. 1 person is slow, 10 person is fast. So by deciding the crew, how many people are working, you can also decide on what they are working on. So are they doing just the carpet, or are they doing the carpet as well as the lining? Carpet and lining is slower, just the carpet, faster. You're the head of procurement. You can decide what you want. So you can actually affect what is the length of the activity. Now, if every activity takes 50 days, which is smart, and you have a housing complex, and you have this staircase, A, B, C, D, then you would, on the first day of the project, you open up the door in the last floor of A, and you say, here you go, Mr. Contractor, go in, do your work, see you in 50 days. And 50 days later, he comes out from section C, last door, and says, here I am. And every 5 days, you let someone in, and all work with the same tempo. Everybody working with 50 days. They never see each other. They never affect any harm to each other. Every time they do the full complete work, they clean after them, they go forward. It's quite easy to manage that project. Okay. So that's the theory. It's very complicated to do, but it's even more complicated if you approve a schedule like this one. So you need to understand what is in the schedule that you are approving, and you need to make sure that you cannot make a perfect world, but you can make a better world for everybody who is working. And then we come into resource-based planning, and this is how I get back to the BIM model where I actually started some time ago. You have the model, you have the geometry, you have the identification that tells the object that can be brought into resources that can be added with time. And now you actually know that in this specific building, on the 3rd floor, in section A, I have 52 columns. My 52 columns require 520 square meters of formwork. My 520 square meters of formwork, when it takes me 0.6 hours per day to build it, and I'm going to use 2 persons to do it, and they are going to work 8 hours a day, it will take me 19 shifts to get the work done. If I want to work faster, I need to add personnel, longer days, or change the work method so that I can work faster than 0.6 hour. It's an open question. Every now and then people ask and think about, now, do I need to plan resources? Don't I buy that service? I make a contract with the contractor or the subcontractor. I tell them, you have 50 days. I don't care how you do it. Why should we? So let's take a look at some studies from Aalto University. A little bit older studies than the ones that we saw earlier. This is from Olli Seppänen's PhD thesis, where he was tracking what happens on-site compared to what was the plan. And you can see now, because now you all read my location-based schedules after the small training session, you can see that there are no collisions. We are using the time quite okay, spread out, but on the lower hand you see these are the resource graph. So the amount of resources needed to do this specific electrical work that is planned. And you see that we start up in the early of the project, we have 1 electrician, we went to 2, 3, 4, 8, 10, 2, 1, 8, 12, 0. What do you think happens when you go on to site? This is a real project. The electrician has signed for this schedule. He has told, yes, I'm going to build like this. What do? They do like this. They always do. Everybody does. They work with constant resources because it is impossible to be economical and make a margin on your project unless you can work with even resources. So you see here, they start with 2, they go up to 3, 4, 5, and they keep an even level throughout the project. And every time somebody shouts that you need to start up there, you need to start up there, you need to have that done, it doesn't mean that it comes magically more people onto the site. It means that they will move to the guy that shouts the most, at least for a while. And that's the outcome of the thesis made by Olli Seppänen. There are 4 different sites from 4 different main contractors, different projects, they all show exactly the same. Planned, signed, approved, and reality. So if you think of it like this, it actually puts the 3D model in the center. And all the data you actually need in order to run it efficiently is the quantity per location. It is the key to it. It is the strength that makes it possible for you to manage the cost, to manage the schedule, the resources, and even the site logistics. Let's have a look at a couple of cases just to see if anyone can actually use this one. This one is Kotikortteli. I worked on it a couple of years back. It's a housing project. Looks like this, quite standard. It's a little bit larger. There are 7 buildings. In the middle of the building, there is a concrete slab. You can park under it. There are some playgrounds on top of it that connects all the buildings together. Problems with this one. First of all, 2 owners. The 4 buildings on the upper half of this one are owned by 1 owner, the lower one, 2nd owner. These owners make decisions on finances in a different schedule. And in this specific project, it turned out that the building permit was missed by a couple of days, which means that we have to build a schedule so that some specific buildings were allowed to start and some specific buildings were not allowed to start. We also built very close to the sea, and some parts went under the sea level, which means that those needed to be in the schedule first to make sure that we don't get water onto the site. But besides that, it's a totally empty site. Where should we start? And as a scheduler, I measured the quantities per locations. I made some 10 different alternatives to figure out which is the most effective way of building, taking into consideration these restrictions of the project. And we came up with a quite nice schedule showing how we go from one building to another with a certain flow, and everybody would be happy. But then it was the groundworks and the piling. It was really, really, really complicated. So even for me and my colleagues, we just couldn't get the schedule to work. None of the scheduling methodologies were good enough to show how the piling is going to be done, because there were several different types of piling, and the piling required that you need to come back to the same exact location several times. You cannot hit all the piles at the same time because the ground was not strong enough for that. So we had to switch over to 4D, and this is what we came up with, which is a quite basic 4D that actually shows how the piling crews are moving on the site in order to prepare for the most optimal way of building the buildings. You see there in the middle, the blue slab is the part that is under sea level, that we had to start with that, be doing the foundations on the round. You can see the piling crews moving around in different locations. But you can also see that when we come into the actual buildings, I switched over to work with Lego blocks. Just these blocks that show that, okay, now we start building this house. Because I thought it's not really interesting anymore. The real challenge was to solve the groundworks here. So we made a movie, we made a contract based on that, we started to work, but also at one occasion I showed it to the design team that this is how we're going to start. And to my great surprise, the structural engineer said, I love the movie. And I wonder why. Why would the structural engineer like this movie? Yeah, because he said he doesn't need a schedule anymore, because from this movie he can see what is the sequence of the building, and these sequences of the building are going to tell him the sequence of how he needs to provide the detailed design of the buildings, what month, what part will be under construction. And I thought, wow. Then it turned out that the sales loved this. how can sales love something that looks like this? Yeah, because a lot of people were concerned that buying into this house is going to be building on for several years. Now, am I buying a house on a construction site? Can I actually live here? Now, this one showed that actually you can, because we're going to sell the houses that are on the top there. We're going to sell them first. You see, it's totally isolated. We keep the site away from where you live. There it's safe to come. It's safe to be. You can live on the site. So that brought to me the strength of communicating through visual models when it comes to designers, when it comes to getting everybody to understand the schedule. Another case is Oodi, the central library in Helsinki. This project was built by YIT in 2005 to 2018. It's a 17,000 square meter building. It opened up in December 2018. The most significant part of this one are the steel arc that you can see on the right side. I know Trimble has used this one in several other cases, but for other reasons. Now, on this one, the problem was this, which was the erection of the framework made by the structural engineer, so the facing. In order to build this one, these are the steps that you need to go through. The problem is that if you follow this one, you end up with a construction time that was longer than was agreed on. And because this central library was supposed to open up the evening before the Finnish National Day to celebrate, you couldn't change the ending date. And we tried to draw on to classic, divide into areas. We tried scheduling methods, and we still couldn't do it. Until we brought that specific thing that was on the drawings into 3D model, showing the sequencing of this is what it looks like when we build according to your plans. And only then did the structural engineer understand that the stabilization solution made for this structure made it impossible to build in the given time frame. What you see here is the solution, because the structural engineer, they changed the stabilization. When they changed the stabilization, it is possible to build all the parts that are on the left side while the arc part is still going on, which gave YIT a couple of thousand square meters of area where they could start the internal work several months earlier, which made it possible to actually deliver on time. Now I connect time a lot of times when I talk. And that's a tricky part, because your model is constantly changing. You constantly get more and more information into it. And when you manage the model and when you manage the projects, you have to manage the information flow. When you start up in early project, you have nothing but assumptions. Your model is based on sketches. You go forward until you can start talking about zones, you have spaces, and you can start building information based on that, until one day you actually have building parts in your model. Now, what should that model process then be? And how do you know what information you need where? You actually need to talk with each other. So bring people together. Ask, who needs what when? This example, I need to schedule in detail the basement. Oh, that's in stage 4. Okay, then I need to do the drawings. And then I can update the costs. Very easy. As we go forward in the project, from stage to stage, we get more and more detailed information into the model. And every decision made affects the information that is in the model. The best way to manage this one is an international standard on level of development, where they have visually brought what is the level of detail, what should it look like, what do I have in model in different phases. This is an American standard used widely around the world. There you bring it into a matrix. You have a classification system, you name all the parts that's going to be in your model, and you start telling that in this schematic design. I need the foundation on level of detail 100 because on that basis I can make the decisions that are important to me. And you do it for the design phases, but you also do it for the estimates. When do you need to do your estimate? What is the level of the estimate that you are going to do? What information you need and at what level then? And you bring it all into the plan that you then use to start or to drive your model. When you do so, you can have in the same model, you can have information that is on different level of details. And you will always know what assumptions can be made based on that specific object at this specific time. You have the identification, you have the data context, you have the geometry and the position, and you can use it to drive your cost, your site, your time, procurement, and logistics. One example of using information over time and tracking it relates very, very well to Jukka's presentation on Trimble Connect. Because in this project, this is OP Vallila, it's managed by Haatela Rakennuttaminen in 2010 to 2015. It's a 90,000 square meter building where we had the full responsibility of scheduling from day one in 2010 up until actually the last parts of the project were delivered. In this one, we tracked the procurement chain from detailed design in structural of prefabricated elements, of what is the level of the design, when it is ready to ship over to the manufacturer, when the manufacturer receives the information, when they start producing the prefabricated element, when it's ready to shipping to the site, when you actually have it on the site, and when it is installed. You already saw the technical demo of it. This is just a case of a project where we actually did it. You can see in the picture here, with different colors, you can see what is installed now. The blue one is what's going to be installed next week. You can also track how far is the design going already. So you have total track of it, of this one. 90,000 square meters, prefabricated, not a single element was delivered wrong time. Real-time update. Okay, then next one. Now when you have a lot of data, then it's a question of what data to use. Now I'm going to talk about just this little graph over here. The blue line in the graph shows the capacity of the prefabrication of the factory. The red one shows the amount of steel that needs to be installed according to the most optimal production schedule. And you can see that the production needs more steel than the factory can provide. Now what do you do then? Two alternatives. Either you need to proceed faster. You need to make it in storage, the steel parts. But if you decide to do that, it means that also your design change need to work earlier. And that was not a possibility. So based on the same information, based on the same data, this one was a procurement decision. All right, if we want to build that building, we need to have two providers of prefabricated elements. Otherwise, we cannot keep the optimal schedule. Same project, same data. You have to make it simple. If you want people to actually take it and use it and make it out on the site, it has to be simple. And this is an example of how you make it simple. You see up on the right part, you see Delete, that is they were tearing down existing buildings. You can see the white one is Lemminkäinen. They are doing this foundation works. You can see the green and yellow part that looks like just blocks, but they're not just blocks. This is the exact amount of how much rock excavation can be done during 1 week. And they are traced to what is the order of doing the rock excavation so that it will always provide the area needed for the next activities. Quite simple mathematics, really, really effectful. And by blocking areas like this, EstCon, we are showing who is allowed to work on what area. Then in the middle, you have the highly detailed structural model, just as it is installed on site on the specific date when this one was used in the meeting. So if you have to manage it, it has to be a process management solution when you go on. And you need to know why you're doing the BIM. There are thousands of reasons why you should do it. You can do it for better project management. You can do it for managing your customer decision process. You can do it for construction design. You can do it for managing the manufacturing parts, just like we did on the Vallila project. Or you can do it for maintenance uses. But you have to know why. And you have to decide it, what you want to exceed. So your BIM goals has to be project specific. In this specific project, we are doing the 3D modeling and the BIM because we want to reach this. And when you have a goal, then you can track it, and then you can react in case of deviations. So it brings you into that you have to manage the process of BIM and the people around it. You set the goals, you communicate the goal, everybody knows why you're doing it, how you're doing it, you agreed on the terms, you agreed on the cooperation plans, and you have the discussion of who needs what and when. And then I'm a big fan of all the lean principles of open communication in order to create conditions for everybody to succeed in the project. You come up with a clear BIM execution plan, and you do constant quality assurance. When it comes to geometry, when it comes to clashes, when it comes to the data content in your model, but also when it comes to order of installation, can you actually build what you have been designing? And when it comes to usability, when it comes to maintenance of the systems that are in your model. You have to remember that if you're doing it almost correct, and you have 90% right, it is most probably 0% that's going to be used. So how much can we save? This is the key question. Everybody asks it. In Sweden, actually, the Swedes love this question. And a couple of years back, every large construction company, their manager stood up on a scene like this, and they said, "We're going to save 10%. And then the next one, so who should he said then? So he steps up and said, 15. We're going to save 15%. And then actually there was one house builder that stepped up and said, we're going to save 20. And I thought, wow, I'm going to buy your stocks. Because if you cut 20% in, say, a year, you're going to be the most value-bringing contractor in Europe. And I'm going to get my money back fast. It's not easy. I can tell you that we did the Vallila project on a 10 million euro below budget and delivered on the exact same date as agreed. However, somebody would raise their hand and say, you must have over-budgeted. Yeah, so much about that. So let's turn it around. How much are you ready to lose? And on that, we have examples. I picked Stockholm Arena again. This is a project where I was invited to come back several years after it was already built, because there were some disagreements on who spent how much money on what. These are in Swedish, but I've done a little bit of translation, and you can see the first one says, arena construction may run late. The other one says, concrete provider bankrupt. Actually, there were two of them. And the third one says, the arena loses 300 million krones, which is 30 million euros. The reason why they lose it? Because they lose income on not having the arena up and running on the specific date where it should be. We went in to see what had actually happened in the project. Why did we lose so much money on it? And we ended up with reading the dates of what time any specific drawing for the framework was produced. We moved it into a movie to make it more visual for everybody to see. We use colors just like in an earlier presentation. Red means late, yellow means red means late and not constructable, yellow means late, constructable, and green means actually delivered on time and possible to build. And this is what it looked like. It has a little bit of a fancy start first, but you see there's Sweden and there is Stockholm, and here we come to the site, which is close to the Globe Arena, ball-shaped old arena. The main part of the text is in Swedish, but you will see this is actually, so we're visualizing by time what drawings are produced in this project, which are the drawings for the manufacturer to make the prefabricated elements. And you can see that we get the slabs, we get the beams, but why it doesn't matter, because we don't have the columns and we don't have the foundations. And you can see that the timeline is going on how many weeks we are late and the total wrong order of producing design information. On this first section, only 4.5% of the drawings were delivered on time if you look at it from constructability point of view. If you only look at how many drawings were made compared to whether they were on time or not, it didn't look too bad.
So design is bankrupt after this question.
And then we go over to the next one. It's a 6-minute movie. Doesn't really change. You see again, next section, a lot of more information is made, but not from the building point of view. So conclusion, you need specific targets. In our projects, it means time and budget. Don't expect results unless you manage the process. Just the geometry and the clash detection, it's never enough if you want to succeed in the project. And you have to manage the data. But when you do, there is absolutely no limit on what you can achieve with the technology. Thank you for listening.